Hey, all you cool kids, it's Wallace here. I want to talk to you a little bit more about shadows. And we know we have shadows because something is blocking the sun's light and it casts a shadow. And it doesn't have to just be sunlight. You could absolutely create a shadow by just using a flashlight. And I'll show you how to do that in just a second. But I want to talk to you a little bit about this diagram. So, what you see here is I have the sun, okay, indicated by our yellow circles. The sun is always going to rise in the east, okay, it's going to rise in the east and it's going to set in the west. So in the morning, when you first get up and you walk outside, and maybe the sun has just come up above the horizon, you're going to be looking towards the east. And a lot of early explorers, they depended on the sun and the stars for their navigation. They got up in the morning, they saw the sun coming up, they knew that had to be the east. Okay, so let's just say, for instance, this is 8 a.m. The sun is going to appear to move higher in the sky, but we know that it's actually the Earth's rotation that makes the sun appear to move. The sun is only spinning in the center of our solar system. It is not revolving or orbiting around any other objects, okay? It's just us spinning that makes it look like the sun is moving. So if the sun is a little bit higher in the sky, we could say that's 10 a.m. If it's pretty close to directly overhead, we would call that noon. And then maybe 2 p.m. in the afternoon, and then 4 p.m., and then it starts to set, okay, setting in the west. So let's just use the example of our 2 p.m. sun, okay? Let's say that we have a lamppost, and here is the sun's light. It's being cast to the lamppost, and we see that the shadow of the lamppost is going to be in the opposite direction of the sun, okay? So it's going to fall back this way. We know from what we saw earlier this week, the longer the shadow, the earlier or later the sun is going to be, right? So if we go to the 4 p.m. sun, now it's going to cast an even longer shadow back this way, okay? The shortest shadow is going to happen right here about noon. We would see just a small lamppost shadow just go in this direction. Okay, so please make sure if you have any questions about shadows, then you make sure and ask, okay? So let me show you another little diagram here that might help you understand that it's really us spinning around, not the sun moving, okay? So what we have here is we have the sun, and you see a black rectangle over here. So this is going to indicate the half of the earth that is in nighttime. This white area facing the sun is going to indicate day, okay? So this is going to be day, and this is going to be night. And I've drawn just a little person here on my model of the Earth. So my little Earth here is blue because we know Earth is called the blue planet. So what happens is the Earth is actually rotating in a counterclockwise fashion. It's the opposite direction that a clock moves. So let's say this is me, and we know the Earth is spinning in this direction. So if I'm right here at this line, okay, I am at sunrise. I am just starting to spin around and actually see the sun coming above the horizon. Okay, so here goes Miss Wallace. The Earth is rotating, and it's about 10 o'clock in the morning. I can see the sun shining, and I continue to spin on the Earth to where I'm almost lined up, and it looks like the sun is directly overhead. This would be about noon. And then we spin a little bit further. Miss Wallace is getting excited because we're getting closer to that 3 o'clock hour. School's about to get out. And then as I turn, now I'm getting close to sunset. Okay, so it's still the end of the day, but I see that I'm approaching that line where I'm about to go into the darkness. As soon as that sun dips below the horizon, that's when we've entered over here. Okay, and so basically, I'm in the nighttime. Miss Wallace is probably pretty close to going to bed, right? It's probably about 8 o'clock, 7, 8 o'clock. And we're going to keep going. And so if this was noon over here, okay, where the tip of my pen is, if this was noon, what would be directly opposite of noon? Midnight. So it'd be 12 hours difference to go from 12 noon over here to midnight. So I'm definitely asleep, okay? and then I'm going to keep spinning around. The Earth keeps rotating, and it's those early morning hours. I may check my alarm, and then, it's time to get up, and there's my sunrise again. Okay, so we know that it takes Earth a full 24 hours to rotate on its axis. So you could divide that in half and say, well, 12 hours is going to be daytime, 12 hours is going to be nighttime. Okay, we know it's this Earth's rotation that causes the day-night cycle. We know that this half of the Earth facing the sun is experiencing day. The other half that's not facing the sun is experiencing night. We know the sun appears to rise in the east and set in the west. The sun is sitting right here the whole time. Okay, it appears to move because we are moving. Okay, we are moving here on the Earth. And then we know that shadows are going to change as the Earth spins, and that's indicated here as it looks like the sun is actually moving across the sky. Our shadows are going to change. Okay, so I hope this helps a little bit, get a little bit better understanding about Earth's rotation and the day-night cycle. Please let me know if you have any questions.